Hello everybody, welcome to this webinar on containerizing Oracle. My name is Deba Chatterjee and I'm the Director of Products at Robin Systems. Prior to Robin, I was working at Oracle Corporation and I was part of the Oracle multi-tenant product management team out there working on container databases and pluggable databases, if you know what I'm talking about. Today, however, I'm going to talk about containers in general and how they are relevant even for traditional monolithic apps running on Oracle databases. So let's begin. So IT departments today, they face a bunch of challenges. I would say a sort of a conundrum that that come from both traditional as well as modern data platforms. So on the traditional Oracle side, what we see is a challenge to contain the cost because there is high database software license related to for Oracle databases and support cost. The ability to to support DevOps-like agility is missing in these monolithic applications. So, to support clone, snapshot, time travel, those type of capabilities. And of course, in trying to ensure performance predictability, that is something that, we struggle with for these Oracle databases. So now, on the other side, with these traditional Oracle databases at one side, we are also looking at supporting these modern data platforms, which provide a lot of operational complexity because of their distributed nature, because of the distributed nature and the use of bare metal servers, we see high hardware capex because they are spread across inside the data center and sometimes even across the data centers. But these databases, these new age databases, they do not provide the enterprise-grade robustness that we traditionally, that we are usually used to on the traditional applications like Oracle, like things like backup, restore, failover, security. Those things are yet to catch up. So with all these problems together, we somewhat are in a need for a single platform where we can consolidate our workload. We can, ensure predictable performance, provide agile data management, and of course, simplify operations for our the IT folks. So with that said, let us find out what are the different infrastructure choices that are typically present in today's IT. So of course, we have the bare metal servers, which I find to be very complex because for every new system that you want to add, if you run on bare metal, you have to add a new server to it. It's difficult to scale and of course very expensive. So this problems with bare metal often led to customers thinking about choosing virtual machines, which tend to have, or we always have, performance overhead because of the hypervisor layer, and definitely leads to virtual machine sprawl and OS sprawl because in each VM you are going to install a guest OS. So we see that happen a lot, that you have VMs and then as the number of VMs go up, the operations activity for these teams also go up at the same time. So it creates a lot of operational overhead. And on the other choices specifically for Oracle, we have purpose-built appliances. Like presume with the X marks the spot, you figure out what type of appliance I'm talking about. They're very expensive and very application specific. You won't use an Exadata to run your Cassandra, Mongo, or any other database. So the need for a single platform where you can actually use it for a database as a service, or to consolidate your databases is the need of the hour. So what are our options today? We have something called containers. Now containers are very popular. In fact, a lot of people use Docker as synonymous to container. But there are other types of containers as well, Linux containers, which were the precursors to Docker. And in fact, Docker was built on top of LXC. So we will, in this presentation, we will see how containers can be used to consolidate Oracle, how you can containerize Oracle database and solve various problems that are associated with running your Oracle databases. So, before I get into the details, I would like to just spend a little time and tell you what are containers. Containers are OS level, very lightweight virtualization. When I say OS level, it is built on top of the Linux kernel itself. And they enable running multiple OS instances or multiple applications on a single host, just like VM do. The containers let you do that. And if you are familiar with Solaris zones, conceptually they are very similar to Solaris zones, and they are actually now standard part of all major Linux distributions like Red Hat, Oracle Linux, SUSE, Ubuntu. So any of these flavors of Linux, they actually get containers out of the box. You can of course use Docker as well, and I'll come to that. So this is basically what containers are, and let's evaluate containers alongside with the other options, infrastructure choices that we had. So, on one side, we spoke about bare metal. So there is a single OS installation. You can put as many applications as you want, but the problem is there is no isolation between these applications. You have to create a lot of rules and regulations to actually make sure that one application is not stepping into other application. Performance is very high, great, because there is no performance overhead. You get the best performance, but it's very difficult to, rather complex to manage. On the other side, we spoke about virtual machines. So virtual machines are, they provide full isolation, but they have a hypervisor layer on top of the base OS, and you have to install a guest OS inside the VM. So what happens because of the guest OS and the hypervisor, we do see some performance overhead. And as I spoke earlier, we also see a big VM, virtual machine, and OS sprawl if you think of putting every application inside a particular virtual machine. So containers are possibly the middle ground between these, and it provides full runtime isolation, just like VMs do. There's no performance overhead because it's built on top of the OS kernel itself, and they are agile and portable, as agile as virtual machines. So I would say it is the best of both worlds, and you can use containers to run any application that basically runs on Linux today. So containers, is probably the best choice because it's simple, lightweight, it provides bare metal performance. You can consolidate databases with performance isolation and performance predictability, and I'll show you how we ensure that on the Robin platform. Unlike virtual machines, you don't have to apply every OS patch on every guest machine, because if you apply the patch on the host, you are covered. They're fast to deploy, and there are other benefits too. So at this point, I am going to refer to a study that we found in the Linux Foundation website. Somebody, has published numbers on how, how it is if you run a workload on a container versus a KVM. You can see on the two sides how different they are. With the same buffer cache being set up, the containers actually provide probably almost 10 times better performance when you look at index reads. DB file sequential reads are basically tied to indexes. So, and also, if you look at the read IOPS, we almost got 20 times better read performance on LXC than KVM. So clearly, some performance tests that we see being done, they are telling us that, hey, containers do provide better performance than normal KVMs. With that said, in last year, we did a we did a survey among our customers, and we just asked them, given these interesting information, are you interested to run databases within containers? Because most people, most IT, enterprises, they are actually looking at containers for stateless applications, but when they look at these, when they see these numbers, they are very interested to use containers for databases as well. So we also asked them, hey, what would be the different key use cases for you to run databases in containers? So what came out is that most of them are looking to do workload consolidation, lower performance overhead, because with VMs they are seeing a lot of performance overhead, improve agility, because you need to adjust to changing SLA needs, so you can move around your databases from one host to the other. If you want to, you can actually using containers. So these are the three primary reasons that most enterprises are looking to containerize their databases. Now, when we come to databases, Oracle is probably the biggest and the largest number of databases in any IT organization. So we want to make sure Oracle can also use containers to, or you can, as customers of Oracle, you can also run Oracle databases within containers. Now, interestingly, Oracle is already looking at this trend, and they have actually published a note. It's in the support.oracle.com. You will see that they have published that starting 12.102, Linux containers are actually supported on Oracle Linux 7 and Oracle Linux 6. So, and Oracle database is certified on Oracle Linux, Red Hat Linux, and SUSE Enterprise Linux inside an LXC. But you have to run on, it is certified on these LXC, but supported only on Oracle Linux as the base platform. So Oracle has already taken notice of this situation, and they have, they have tested their databases. So on Robin, when I go through the presentation, and by the way, I have not mentioned this, you feel free to send in your questions because at the end of this presentation, I would really like to answer those and have sort of a discussion around this topic. So you see here, Oracle database is already supported on Linux containers. But what about Docker? Because that seems to be the more more interesting, more popular container type, container platform. So I was looking at the Docker Hub the other day. Although Oracle officially doesn't support Docker yet, but there are Docker enthusiasts that have built many Oracle database images. In fact, it is extremely easy to run an Oracle. I found the Docker image for the Oracle Express Edition, and I did a Docker pull, download it on my laptop, and I could run it in like 5 minutes, less than 5 minutes. So although it's not supported by Oracle, or neither it is certified, but I do think in the future, in the near future, there would be, Oracle would take notice about the popularity of Docker, and they are going to support running Oracle databases inside a Docker container. And you can see there have already been thousands of downloads in the last few months itself. Interestingly, Oracle, I found a GitHub repository for Oracle-based Docker images, and I also saw a Docker file which you can use to create a Dockerized image for the Oracle database, just a single instance Oracle database, but there are Docker images available for other Oracle products as well. So with that said, I want to now jump into the other part of the presentation. How does we at Robin Systems trying to help Oracle customers containerize the database? So before I get into the details, I just want to take a pause and basically talk about our company itself. So, Robin, our motto is to create an application-defined data center with, with our container-based software-defined infrastructure. So that will help you to simplify application deployment and operations. It will help you to, let's say, consolidate applications with guaranteed performance isolation. And of course, one of the needs, if you remember earlier, it will help you to maximize your hardware capacity utilization. So with that, this is sort of what we do. And how does Robin work? That is also, would be a very important pertinent question here. So Robin works on top of any existing commodity hardware, and what happens is that it aggregates compute resources across servers to create what we call an application-defined compute plane, where applications are deployed as containers. And integrated with this compute layer is our application-defined storage layer. It is a scale-out block storage, just like block storage works, that provides capabilities such as guaranteed IOPS, distributed snapshots, and cloning. And of course, like standard features, those are table stake features to these days, such as thin provisioning, compression, encryption, and replication. Now, these two components are tied together by what we call the Robin Fabric Controller to create a very fluid, elastic infrastructure platform for modern and traditional data applications. So, and also, we also plan to support cloud in the near future as well. So, as I want to, this is basically a single platform where you can run all your data applications without any changes to your app, with all your data apps, but you have to make no changes to those applications to get on to onboard the Robin platform. So by using containers, Robin helps you to consolidate multiple applications per machine and eliminates the need to have dedicated infrastructure per application. So, in the good old days, we used to have, okay, this machine is for that application. Instead of that, we are creating this whole plane of compute and storage on which you don't have to dedicate infrastructure per application. You just containerize your apps, and apps are actually running inside these containers. And while containerizing your application, Robin ensures that each application is guaranteed the same performance as if it was running on dedicated infrastructure. And in fact, Robin is the only infrastructure platform that I know of can consolidate application without compromising performance or predictability and making no changes to the application. In fact, it works exactly the same as it would work on a non-containerized platform. So, and finally, Robin sort of dramatically simplifies application operations. So, you can deploy, you can clone, you can time travel even the most complex applications within minutes. And, I personally think that with all these capabilities together, Robin can double or triple your capacity utilization, help deliver predictable QoS, and dramatically accelerate your go-to-market. So, in this particular slide, you can see how we can support both types of containers. We have support for both Docker and the system containers. And the message that I want to give out is that you don't have to, if you select your Oracle database to run on an LXC container, but you can still use your WebLogic component to run on a Docker container, because that's what Oracle has already certified. And you can also define a performance or SLA tiers for your application, and Robin will automatically understand these gold, silver, and bronze classes, and it will treat those applications based on those given priorities. And most important of it all, it works exactly the same for Oracle or Postgres, Cassandra, Mongo, MySQL, any application that you can think of, even Hadoop. the same platform can be used for any of your data applications. So let me move on. So what about the application fabric controller? So the application fabric controller, in my mind, is the brain of the Robin platform. So it helps you to, basically simplifies our life by helping you to provision containers. It takes care of the storage, network, installs, and configures your applications as well. So what would have taken you days or weeks otherwise, it can be done using minutes on the Robin platform. So also the other thing is that the fabric controller guards your application from hardware failure. So let's say if you have a application running on 3 separate nodes, one of the node goes down, the fabric controller would actually monitor the availability of the node, and it will actually fail over that container from one node to the other. So, and also, it goes the same thing for the storage. So if the storage, something goes wrong with any of your disks and or storage servers, Robin, actually the fabric controller automatically initiates disk repair, and it provides the same enterprise grade data protection that you get from some of these very expensive storage arrays that are available in the market. It also supports both replication, asynchronous replication, synchronous replication as well, eraser coding, and all the basic storage capabilities that you usually can think of. So, and also this is very interesting. As I told you before, we can actually snapshot and clone our entire application cluster in a single click, and matter of minutes, because we use thin provisioning and regardless of the data volume. So even your multi-terabyte Oracle database cluster can be cloned with minimal storage to create your dev and test systems. So I would say next time if you are running your database on Robin, you can be a real hero, because you can restore your database back in time, because we support time travel with a single click of a button. So and you can basically recover from any failures without I would say without sweating much. And I'll actually show you how you can do that. I have few demos during the course of the presentation, which will help you to understand this platform more. So with that said, let me get into the nuts and bolts of the Oracle database. So I have 4 demonstrations. I hope I'm doing good on time, and I hope I'll be able to cover all of those. Those are recorded demonstrations. So let me start with provisioning. So this flow probably looks very familiar. You can see how traditional deployment worked. It had a developer or a group of developers would request a database that would go through some approval chain. It goes through the DBAs, who request hardware and storage. They allocate, the storage admins would allocate storage, set up OS, network, then the DBA comes in and creates the database, configures the database, and the developers get access. So sometimes it used to take days, weeks, and months. Once, while working at Oracle, I want to share this story. I went to visited a customer in one of our neighboring countries here, and they said, "Oh, this is a government customer." I said, "How long does it take for you to provision database?" He said, 6 weeks. I said, "Wow." The person told me, "Yeah, sometimes I forget that I have requested a database, and then suddenly six weeks later an email comes in saying that your database is ready." And she was telling, "Oh, my database is ready? What database did I request?" So something like that. You tend to forget what you did 6 weeks back. So at Robin, we want to dramatically simplify this whole process because we have created what we call image from containerized images Just think about Docker Hub, or for the lack of better term, we have LXC-based images for LXC-based images for the Oracle database software. And you can see on the screen we have Oracle single instance, we have Oracle standalone on ASM. I have an image where it accepts all sort of inputs and then creates the Oracle database, and then we also have an image for Oracle RAC. So what you need to do is basically select an image from the library, and it then opens up a screen where you can provide bunch of inputs. I'll actually show you in details because I have a recorded demonstration. And then once you have provided this inputs, all you need to do is say provision application, and your database gets created with your specified volumes, memory, and CPU configuration. And this whole thing, even for a very complex application, complex database, let's say a RAC database, it can be done in 5 to 10 minutes. It is not an hour or a day or weeks, like I gave you the example. It is really 5 to 10 minutes. You can get your database up and running with the configuration that you have asked for. So how does this work? And before I get into the demo, for you to understand how this works, I'm going to sort of give you a very high-level view of how we have created this architecture. We have what we call application bundles. So here it's the image of the software baked inside baked inside a containerized image. You have to define what we call an application manifest. This is basically a file. It's a YAML-based file that actually has the anatomy of your application. And in the next slide, I'll show you how it looks like, and which defines the application topology. What sort of environment variables you want, what sort of QoS requirements, and so on and so forth. And then you can also have scripts that you can run as part of configuring your system. And we support both containerized images, both LXC images that you can get from the Robin image repository, or we can pull in images from Docker Hub or any private Docker, trusted registry. So with that said, let's look at a manifest. So on this side, as I was saying, application manifest is a YAML file where you define different roles, that components that make up your application. So on the left side, you see I have a manifest for the Oracle ASM application. It's a ASM based storage running a standalone database. Here there is only one role, Oracle, but this file can be extended. It can be, you can add more and more roles to create a whole composite application itself. And all you need to do is make sure that these components can talk to each other. You can glue them together. And how do you glue them together? Using the Bash script, Python script, Ansible scripts, with those use of those scripts. So you can define resource requirements, your CPU, memory, storage. You can apply QoS policies. You can pass in environment variables like IP addresses or database names. You want your database name, to something. So you can actually make those environment variables, or you want to have pass in the character set of a database. So you can actually define those as environment variables, and those will be exposed in the Robin UI. And then you can define multiple action hooks. Each operation has a like operations like start, stop, create, snapshot, clone, all have a pre-hook and a post-hook. So you can write scripts that that will do a certain action after or before the operation is done. So I'll give you an example. Let's say you are cloning a database. You can define a post-clone hook on Robin that will call some masking API, and it will basically mask the the sensitive data like SSN credit card numbers on the database. So the other component, as I said, is an application template. So this application template is basically a file that is generated after you have provided all your inputs. you can save it and use the template to create the similar application again and again. So you don't have to provide the input all over again. You just save your inputs in a file, and this is a JSON file, and it can be reused to create similar databases every time you use this particular JSON file. And you can, of course, always customize this script. So now let's do our first demonstration. So let me move to my other screen, and I will start this demonstration. And if you look at the screen, you see there are 4 images for Oracle. I have selected the Oracle ASM application. I'm providing a name, an ASM test, and here I will provide CPUs and storage, different devices, and then change the name of the ASM disks. And now here I can save this application template, and now I click provision applications. This is the part where you have to wait and see how quickly applications can be provisioned, because I have already a containerized image for Oracle. I don't have to do a run installer, install Oracle or anything. It's already pre-baked. I'm just calling DBCA, ASMCA in the backend to configure the database. Now it's already done. There is some video magic here. It takes about 5 minutes to complete, and it's basically based on your inputs. This database got created with 4 cores, 8 GB of memory, and now you can also access the database directly from the UI. I'll go into the Oracle user, and I'll source the environment, and now you can see that the ASM and my database is running. So what I'll do here, I'll just want to show you the file names that got created, and I'll create a just for fun, I'll create a pluggable database. I love PDBs, and it gets created. I'll alter the database. You have to open the PDB, and then I will alter session set container into the PDB, and you will see that the files for the PDBs are also created in the ASM environment that I created. So if you notice at the bottom of the screen, I have at the bottom of the screen, I had this ASM devices, which I actually passed in at the time of creating this environment. So these are basically, as I mentioned earlier, these are basically block devices carved out of the Robin storage layer. So they are virtual block devices that actually spreads out the data in all the storage servers that constitute the Robin storage platform. So that's where that's how Robin works. So, but for Oracle, it just thinks that okay, these are block storages attached to the container, and they can write data just like they would do for any ASM-based databases. So, we as I was telling you that on our platform the block size that we support is 4 kilobytes block size, but Oracle likes to use 512 byte block size for the OS block size. So you can also create devices on your choice of block sizes, and use either 512 bytes or 4K block sizes depending on the type of application you're using. But for Oracle, I think 512 byte block sizes are recommended. Don't confuse it with the database block size, which is basically 8 kilobytes, but this is the OS block size, the storage block size that Oracle recommends to use. So let me go back to the presentation now. So now I'm going to talk about something that is very critical for a lot of database administration. It's the cloning of an Oracle database. So, cloning is probably the biggest reason we see data sprawl, because any environment that we run any production environment that we run, it almost leads to at least 10 downstream copies, because developers need dev test environments, and DBA spend a lot of time in creating these environments for developers or QA needs. So when you have a full clone of a production database, it's either very time consuming because you have to do the whole copy of the database, and this results in data sprawl, and sometimes you cannot create a lot of available tools in the market. They talk about creating a test master, because you do not want to access the same data blocks from your production and your test and dev environment. So what happens is that you end up creating a test master, so you eat up more storage, then you create all these environments, downstream environments for dev and test, and then as you create more and more, you basically run out of storage. To deal with this problem, or Robin provides a way to create these environments as you need, but you don't have to pay the storage penalty. So what happens is that built on top of Robin, we have the ability to do thin clones. So Robin storage is built from the ground up to help to allow thin clones or copy on write clones. So if you have a database like this one running with different data volumes, we just don't do a snapshot of just the data volume, or we actually do a snapshot of the entire container and all the data volumes. We take a point-in-time snapshot of all data volumes, and then it's a time-consistent copy with minimum space usage. And then we basically simply add a container on top of the storage to give you a clone of your database. So as a result, multiple clone copies of your production system can be created with a fraction of storage. So basically, you can create your dev, QA, all these different environments, but only spend a very little amount of storage, because these are all thin clones, and they are brought up, they are created almost instantaneously. So here, at this time, I'll actually show you. I'll move on to my next demonstration. So I'll move to this, and here I have a database called Oracle 3. You can see that this running, and it's running in the container host 895robinsystems.com. This database is actually, I'll just make sure I'm on the right host, and I'll do a SQL plus, log into the database, and select the name of the database just to make sure it's CDB1. And I have a PDB called SOE. SOE is the order entry pluggable database. I'll log into this pluggable database now, and I'll do a select count star from orders, just to show that I already have a bunch of orders, 1.61 million records. Now I'll use Swing Bench, which is quite a popular benchmarking tool, to connect to this SOE PDB and create a workload. So now I'm pumping in orders into this database. So you can see on the right hand side, I'm hitting transactions like 165 transactions per second, about 3,000 transactions per minute. So now I come and check whether how many orders are entered, like 2,000. So I have reached a steady state where let's say I want to have a requirement to create a clone. So at this point, I'll create what we call a Robin snapshot. And see, the load is still running on the right-hand side. I haven't touched, so your production is running. No need to create a read-only or take a downtime. So create the snapshot, and immediately, this is what Robin does. On the right-hand side, you'll see a small blip. It's a sub-second blip, and then the snapshot is created. So that's when we quiet the I/O and create a consistent copy of the database, and then we use that snapshot, say, to create a clone. So I'll name it Oracle 4 and select unfenced mode. I mean, this is something details to the application, and this is actually in real time. We created the snapshot. Now we are provisioning the container as I explained in the slide, and my database is now ready. So I'll close it, and you can see Oracle 4 created from Oracle 3, and it has a new container host name 89114. So I'll log into that system, and I'll provide the password and source the environment just to set up the Oracle home, Oracle seed, and all those things. And then now I will start the database. So in fact, I am starting it for you, but if you remember the post clone hook, that could have been written in such a way that it would have automatically started the database. So now the database is started, and I will actually now log into the database and see how many orders have been created. So it should be somewhere between 8722 to 8801, because that's where we took the snapshot. So we connect to the database now, and using simple localhost, the quick connect method, and select count star from orders, and we see that there are 1620925 orders, so which is between 8722 and 8801. So that's when I took the snapshot, and that's the number of orders in there. So now I can also, on the other side, on the production side, the transactions are logging in. So I haven't stopped those transactions. So this is how cloning works on the Robin platform. It's very simple for Oracle databases. I have been a DBA in my past career. This would have been a real asset to my reporter if I had we had this in the past days. So now let me move on to the next topic. So this is a very interesting ability. So when we build a platform, we have something what we call a feature, the ability to create snapshots. Now, snapshots are used to create clones. You saw how we have used it to create clones of the database. But snapshots are also useful if you have to roll back your databases to a certain point in time. It's similar to flashback, but without have to create without have to set up flashback on the database side. Robin actually takes care of the setup. So what happens is that, let's say you can set up Robin to take snapshots at every period. So let's say I take a snapshot for period 1. Now let's say the data has changed, and we take another snapshot. Like you see, I have orange, yellow, and green. And then you perform a database upgrade or apply a patch. And as a result, now you have data corruption, you have a bad upgrade, and now your database is not usable because it is no longer working. So what you can do here is that without Robin, you have to restore back from your backup, apply your archive logs, roll back the patches, config changes. It's a huge list of things that you have to follow in order to get your database back to shape. But with Robin, all you need to do is go to the snapshot and say, restore me back to this point right before the upgrade, and you are back up and running. So you don't have to do all this manual work. It's just a single click of a button that actually lets you bring back your database to a particular point in time. So it's definitely a very cool feature for all my DBA friends. The next topic on the this section is about quality, about QoS in an Oracle database. One of the biggest challenges for ensuring, app to spindle IOPS is that you have this feature from Oracle is only available on Oracle Exadata. You cannot get it on non-Exadata hardware. So at Robin, we thought that this is an interesting problem, and we have built this on all the for all your databases. So it works exactly the same for Oracle or a Mongo or a Cassandra or an Elasticsearch. Any data application, they can leverage this feature. So how it works, it controls resources and enforces priorities in the compute, network, and storage layers. You can create a per rule IOPS cap and a guaranteed minimum, and you can also increase these limits as and when required. You don't have to bring down the application; it just works as is. So I'm going to show you a quick use case. So previously, a lot of our customers, I'm talking to, they don't do direct cloning from production, but hey, we can clone directly, live clone on Robin at this point in time. So why not clone directly from production? But then you will say, hey, since it's a thin clone, the I/O is going to hit the same data blocks. So, but with Robin's I/O resource management, we can actually prioritize the IOPS from the production over QA. So even though they are hitting the same data blocks, we would be able to say that your test environment has a much lesser IOPS over your production database. So you will see that the production, although has much greater I/O priority, but the test instance will have much lesser priority, because what the Fabric controller does, it basically allocates two separate I/O channels, and that actually prioritize the production I/O channel over the test or dev I/O channel. So creating thin clones and ensuring IOPS is very easy. There's other use case, and this is what we call scaling up. Scale out is a very popular term. Everybody knows about scaling out. That's what the distributed databases they do. But scaling up is something that you often need, because you have to pump in a lot of let's say during Christmas or Thanksgiving, you have more transactions to handle. So you wish if I had 2 more CPUs during this time. So what you can do is you can actually right size your cluster depending on your workload. You can define policies that can actually do that. So what you do, you can increase the number of CPUs on the fly, and then the containers actually have more CPUs to work with. You can also, when sometimes CPUs don't, scaling up just CPUs don't work, so you may actually need to scale up your, to increase your IOPS priority as well. So what I'll do, I'll just increase the IOPS here, and you can see the IOPS capability, IOPS bandwidth for these databases have gone up. So you can actually, what I call scaling a database or scaling an application or scaling a cluster vertically by dynamically adding resources for transient peaks. So you can actually scale up or down depending on your workload or using on the Robin platform. So you don't need to basically redistribute data, and you can make these changes as a temporary on-demand resource requirement, and then put back the original configuration when your workload has gone down. So with that said, let me go to my next demonstration here. This is a very simple demo. I mean, I have never done this on a non-Exadata hardware. During my Oracle days, we only spoke about I/O resource management on Exadata. But here I'll show you how easily we can control the the IOPS requirement for a database. So here I have a very large table running on this database, and there is no limit. It's like 50,000 IOPS. That's the whole capacity of the disk that I'm running on, and I'm going to run this account star from this t_obj table, which is 93 million records. And when it is running, I'll go into my system, and you can see that I'm hitting about 55,000 IOPS, and it's like 200 megabytes of data being captured. So this one takes a minute and 3 seconds. So you as a DBA, you wonder, if I run this, let this system run in parallel with other systems, this will flood the IO subsystem. Is it possible for me to reduce the IOPS requirement for this database from 55 to some lower number? So what I will do, I'll go to this application, and I will reduce that read IOPS from 50,000 to, let's say, 10,000, and hit apply. And without even logging out of the session, the same SQL Plus session, I'll go back to the database and I just run the same count star, from that table. And now if I look into my storage subsystem, you see that it is down to like 10,000 IOPS per, IOs per second. And this actually takes a while. If you remember, it took 1 minute and 3 seconds. This time it takes 5 minutes and 12 seconds to complete. And this is how you can have throttled down the IO from this particular database. So you can also do it at at an application level. You can define different roles as well. So for the interest of time, I'll stop here, and then I'm going to move to my next topic, which is failover and relocation of Oracle database. So this is a very important topic. A lot of our Oracle customers spend a lot of money to set up rack and rack 1, different Oracle restart, different ways to protect their databases from going down. So we at Robin have actually, our application fabric controller, we can detect, automatically detect container failure, and we can move containers from one server to another server automatically. And I actually will show you a demonstration as well. So here, let's say this compute node for this database goes down. What will happen? The fabric controller will automatically spin up the container on another node, and in seconds. And it will it will automatically mount the storage volumes to the new container. So if you have a decoupled compute and storage, if one of the compute node goes down, it will just bring up the Oracle container in another node, but the storage layer is not impacted. And it just spins up the container and repoints the storage to the Oracle database. Now, if the storage node goes down, we have support for replication, 2-way, 3-way, eraser coding, and then also it just reconstructs the volume and mounts it to the container. So that's also an operation that takes few seconds. So before I summarize, let me show you a demonstration on this topic, on the failover use case. So I have on this system, I have 2 hosts, 8220 and 8219. And 8220 is just a compute node, and this is a hybrid, so it has both compute and storage capabilities. So what I'll do is I have one application running. You can see that they are. I go to the applications tab in Robin, and I can see on the Oracle prod database application is running. So it is running on C-Scale 8220. You can see the physical host. Now we have a command line interface. I haven't shown you this command line interface before. I can see the command Robin host list. I can see the same information out there. Do Robin instance list. And I see the container that's running on Robin. Now what I'll do, I'll just run a count star from the DBA objects table. So it just connects to the database and runs a count star. So at this point, it runs again, and the next time it fails because there has been some failure. So we'll have to see why it has failed, and I can see the 8220 host has failed for some reason. So now I move back, and by the time I do a Robin instance list, and this is actually very interesting, I was having a hard time to do this, build this demonstration, because by the time I came back, the application fabric controller has already detected that the database instance has gone down, and it has failed over the Oracle instance from 20 to 19. And if you look at the script below, that is again running just fine, because what happened is that it brought back the instance, and it's you relocated the container, brought back the instance, and the script was running. It was just periodically polling the table, so it just reconnected to the database as if nothing happened and started working. One very important point I have to make here is that we retain the IP address of the container when we are moving from one host to the other. As a result, there is no change in configuration of the application. So when the container is moved from one point to the other. I hope that's a very convincing statement. You saw that. So now let's summarize our presentation, because I want to have some time for Q&A. These are some of the highlights that we do for Oracle: DevOps, Agile DevOps. This is something that the things that I showed you, are very, I would say, difficult to set up, or you would need a lot of different tools to set up thin clone and relocation and instant scaling. There is no one tool where you can get everything. So Robin provides you that, and it's not just for I want to make this message very clear. Not just for Oracle, for every other database. So it's a one platform where you can support heterogeneous set of databases. It's your one platform for database as a service where you can guarantee your QoS for all your databases, so that you are not, you prevent noisy neighbor problems. You can not only guarantee maximum IOPS, you can also guarantee minimum IOPS for applications. This is, I don't know of a single platform that actually does that. It works on your on-premises existing commodity hardware. We have simplified database management where you can provision very complicated applications, including Oracle ASM RAC, with a single click of a button. We have ways to simplify your patches and upgrades. I didn't even cover that, but we are doing something very interesting in that space as well. We have instant point-in-time restore through the time travel capability, if you recall what that I shared. And of course, because we are using containers, we can ensure bare metal performance, and there are no performance overhead, and you can run your production system side by side with your test and development environments. So with that said, I will actually summarize your, I will summarize sort of the different consolidation options. I guess, virtual machines have performance overhead. Multi-tenant is a very good consolidation choice, but because we share redo logs, there are certain noisy neighbors problems which are not addressed. Containers are very negligible overhead, completely independent, no hypervisor. Availability of VMs are high because you can move around VMs, but with multi-tenant, I think that's where there is a problem. Patching becomes a problem because you have to patch, you have to take all the applications down at the same time to apply patch to an Oracle home. We have a solution for that. We provide performance predictability. There's no way you can do it with IOPS. It's not integrated with the application. A lot of storage vendors provide you IOPS control, but you cannot really do it from the application layer. Robin actually provides you that. Since it's application defined, you can go into the application and say, hey, I want to control IOPS for this app, and that's how you can. You don't have. It is not that you have to go to the storage layer and control it separately than from your. And there's no scripting or handshake involved in it. It's just in one place. You can just use a slider to control IOPS in Robin. So with that said, I think I have about 2-3 minutes. I am seeing there are a few questions from the audience. So the first question is, does Oracle support deploying, does Robin support deploying Oracle RAC on containers? Yes, we do support deploying Oracle RAC. It is basically, you will define the number of containers you want as RAC instances, and they will be deployed, and the image already has a grid and Oracle home provision. Or all we do is basically run the scripts for, it's like a silent install or configuration of ASM and the database. So basically, whatever time it takes to run ASM CA to configure the ASM instance and DBCA to create the database. So probably for a 2-node rack instance, I have done this in like 10 to 15 minutes myself. So yes, the answer, the short version of this answer to this question is yes, we do support Oracle RAC on Robin. Uh, Next question is, can I create container bundles for other Oracle products like WebLogic? I think I mentioned this already. Oracle's GitHub repository, they provide these scripts, the Docker files with which you can actually build Dockerized images for a lot of the non-Oracle products. If you work with us, we will also help you to create the LXC bundles for these Oracle products. So again, the answer is yes. Let me see another question. When you have that database running in a container, does it support all typical access? Yes, it does support, because we are creating a very simple, as I mentioned, one of the prime requirements that our motto is that no changes to your application. So whatever way you have been using your application, exactly the same way will work. So you can do SQL Plus, you can do, you can use your SQL developer to connect. The container actually gets a host name and IP address, so you can use that. Second question is about agility. How do you move a RackDB from container A to container B to offer, say, as part of? Actually, you don't move the container A to container B. You are moving the container from host A to host B. So it's a simple relocation command will actually move the container from one host to the other. And we make sure we have what we call affinity and anti-affinity rules, which actually allow us to ensure that two containers from the same rack instance are not running on the same host. So we won't put the other container in the same host where the other rack instance is running. So we are also working with our partners to make sure that we can also provision a standby database using a container on a different host. I'm getting different requirements, so we are working on that. So at this point, another question just came in. So do we have an offering in the cloud? So as I mentioned, we are working on it, and we will probably have something as early next year. So you'll be able to run Robin on the cloud as well. So with that said, I think we are done with our presentation today. Feel free to reach out to us. I'll be more than happy to answer your questions, and if you have any interest in Robin, you can download our white papers, you can look at our demos, and we can definitely reach out to us whenever you want. Thank you so much for listening and being patient and watching these demos. Thank you.